Hi Coachella and Mr. Miller. This is the tutorial for using a real-time clock. Let's go. This is the tutorial for displaying the date and time using the LCD screen. First thing we're going to do is we're going to include the Curie time library using the include function here. We're also going to include the liquid crystal display in our code. We're then going to use liquid crystal LCD 12, 11, 5, 4, 3, and 2. That's going to be the pins that the liquid crystal display board is attached to on the Arduino. Then we're going to start the LCD at 16 times 2, so that's the number of spots on the board that we can put info into. We're going to then use lcd.clear to clear the board. And then we're going to use the set time function here to set the time that it is and date that it is currently. We're going to set it to 8:49, 30 seconds, and on the 31st of March 2019. Then in the void loop, we're going to create a character array of 16 characters for the time using the char function, clock time 16. But then you can use the sprintf function here to create a time string of the hour, minute, and seconds using this clock time function here. And we're going to create another array of 16 characters for the date using the char function again. We're also going to use the sprintf function again to create a date string for the month, day, and year here. Then we're going to use the lcd.setCursor to set the cursor to column 0 and row 0, so 0, 0. And we're going to print the date string over the LCD, so using lcd.printDateTime, so that's going to be on the first line on the LCD screen. Then we're going to set the cursor to column 0, row 1 for the second row down. And we're going to use the lcd.print function again to print the clock time string over the LCD. And that's it. Here's the basic board for using the onboard time clock. Here we have the LCD screen wired in same way as the LCD tutorial, but we can explain it again. Here it is grounded by this brown wire here. It's connected to the 3.3 volts through this white wire and then through the red wire. The next pin here is going to be this orange cable here, which is the LCD operation voltage test pin, and that's going to connect to this potentiometer that controls the contrast of the board. The next wire here is this yellow wire here. It is the data and control register select input. That's going to be connected to pin number 12 on the Arduino board. Then we get to this green wire here. We get to this brown wire here. That's going to also ground the board for that. And then here is this green wire here. It is going to start a signal for reading or writing data, and that's going to be connected to pin 11 on the Arduino. We're going to skip a few spots down to pin 11 here by this yellow cable here. This yellow wire is a data bus bit number 4, and that's going to connect to pin number 5 on the Arduino board. This orange wire here is data bus bit 5. The next yellow wire is data bus bit 6, and the other orange wire is data bus bit 7, and they're connected to the pins 4, 3, and 2 on the Arduino board. And then here, this white wire here is going to connect to the 3.3 volts, and it's the backlight positive pin, and this brown wire here is the backlight negative pin, and it's going to connect to the negative column of the ground. Then we get to the potentiometer. It is connected to the LCD screen through this orange cable like we said before. It is grounded by this brown wire here, and it connects to power through this white wire to the 3.3 volts. Here the red wire connects the LCD and the potentiometer to 3.3 volts on the board here, and then the black wire grounds everything through connecting to the ground pin on the board. And we can see that the LCD screen is working. It displays the date and the time, accurately counting the seconds and the minutes. So there we go. This is the modified code for using an onboard time clock. What we're going to do is we're going to still play the display the date and time, but we're also going to have a running countdown of 10 seconds, and once those 10 seconds are up, a LED will turn on and a sound from the piezo buzzer will play, and then it will reset. So again, we're all going to include the two libraries here, the carrier library and the liquid crystal, and then we're also going to start the liquid crystal on the pins that it is connected to on the Arduino. We changed the number a little bit this time because we have the piezo connected as well. So it's 13, 12, 5, 4, 3, and 2. We also created two constant integers, a buzzer pin connected to digital input pin 9 on the Arduino, and the LED pin connected to digital input pin 10 on the Arduino. We also created an integer I that we'll use when we are doing our countdown for 10 seconds. We get to void setup. Again, we're starting the LCD at a 16 by 2 screen, and then we're going to clear the LCD just to get anything that was on the screen beforehand just gone. We're going to set the time to where it is right now, and then we're going to, using the set time function here, it's going to be 12 o'clock, 40 minutes and 30 seconds, and then April 3rd, 2019. We're going to use the pin mode function here and here, the two pin mode functions here to set the piezo buzzer as an output and the LED pin as an output as well. And then we're going to start our serial port at 9600 BAUD using our serial begin function. When we get to void loop, again we have our character array here of 16 characters for the time, using clock time, the char function. Again, we're doing the sprintf to create a time string for the hour, minute, and seconds. And we're going to do the same thing for the date time, using the char function to create an array of 16 characters for the time, and using the sprintf function to create a date string for the month, day, and year. Then we're going to set the cursor again to column 0 and row 0 to print the date time over the LCD again. That's all the same. This time we've also added in a serial print function here, so we're going to be able to see on the serial monitor what is happening on the screen. Again, we're going to set the LCD screen, the cursor, on the LCD screen to column 0, row 1 to print the clock time using the lcd.print function here. So that's going to print the time, and then we're going to again use the serial print function here. Serial print function here to print clock time equals, and then serial print ln the actual time that it is recording, and then we're going to make a new line using ln. Then we're going to set the cursor to column 11, row 0, using the LCD set cursor. So that's going to be on the same line as the date, but it's not going to be interfering with it. And then we have a for statement here. So when the integer that we defined up earlier, I, is, so that's going to we're going to use now. So for when I is 9, or it is greater than or equal to 0, then we're going to decrease I by 1 each time. So first what we're going to do is we're going to use the LCD print function here to print the I value on the screen. And then if I is equal to 0, we're going to play our sound and our LED. So in order to do that, we're going to use the tone function here to play our sound. So we're going to define the pin that it is playing at, the hertz that it the frequencies at, and the duration of the sound. And then we're going to serial print the play tone, so we know what's going on our serial monitor. Then we're going to use the digital write function here to set our LED to high, and in other words, turn the LED on. Again, we're going to use serial print here to print a space and then the LED on our serial monitor. We're going to delay for 1 second or 1,000 milliseconds, and then we're going to use the digital write function to turn the LED off. We're going to use serial print it to tell the serial monitor what is going on, so we're going to tell that it's print the LED is off, and then we're also going to use the no tone function here to turn off the tone, so it won't continue. And then we're going to use the serial print function again just to print out that there's no tone playing on the serial monitor. We're then also going to reset this cursor at 11 column 11 row 0, just so that for the next number it'll rewrite over the previous number, so there won't be leftover numbers. If it is not 0, we'll use this else function here, and we're just going to have a delay for 1 second, so it's going to be in time with the 1 second. And then we're going to reset the cursor at column 11, row 0, so that we can overwrite the numbers. And then we can look here on the serial monitor, once it loads, that we can see what's going on the board. There you go. So that's going to show up every 10 seconds. It's going to tell you the date, the time, and when the tone goes on and off. So there we go. That's it. Here's the modified board for using the onboard time clock. Here we have the LCD screen wired the same way as before. We've just moved up the potentiometer to leave more space for the LED and the piezo buzzer, and we've switched the wiring so it leaves pin 11 open. When we get to the LED here, it is connected to pin number 10 through this yellow wire here on the Arduino, and it goes through a 100 ohm resistor to the anode of the LED, and then it is grounded by its cathode by connecting into this negative column here, and then grounded by this black wire. And here's the piezo buzzer here. It is grounded by this gray wire here, connected to the negative side of the piezo and to the negative column here, and then it is connected to pin number 9 through this white wire here. As you can see on the board, it still displays the date and time, but now it shows a countdown for 10 seconds, and every 10 seconds the LED and the buzzer will sound.